Dear students, good morning. Welcome to the second session of the topic related to the safety and protection of the EEE subjects. Let's go to the flow of the session. In the previous session we have gone through the introduction, shocks of the electrical, then safety rules, use of the multimeter, grounding, importance of the same. Up to that one we have covered also this circuit protection devices like fuses, MCB, but introductory part was the same, and for the same today I would like to go into the details of the same. Circuit protection and the devices. The circuit protection is the very important thing with respect to the equipments or the circuit, because if fault is going to occur ever, then it's going to happen that equipments are going to become the faulty, malfunctionings are going to be there, and at the same time the human life is going to be into the danger. So that's why it's very important to have the protection of the electrical circuit for our work purpose also. Now let's go into the introductory of the same. As we know, this electrical unit is built with the great care. We are going to provide the safety for the electrical apparatus or of the equipments, so that we can insulate one circuit from the another circuit, and we try to make it that current should flow from the intended path. Over here intended path means from the path from which we want to make it to flow our regular circuit, our working circuit. But still, what happens sometimes, the parameters of the circuits are going to be changed, and that parameters may increase. That parameters are called the excessive. More amount of the parameters are than that what we have thought about it, and that parameters of the systems are going to create the problem into the system. So it's very important to detect all that parameter, whether voltage is there, current is there, earth problem is there, at very right time and at the earliest, at into the beginning of the problem, so we can overcome that problem. Now what happened, while circuit protection devices cannot correct an abnormal condition, over here the abnormal condition means the fault conditions are there. If they are not able to correct it immediately, but still they will give the indications of that existence of particular conditions, so that at least the person and the circuit can be protected by the another means, by the our intellectual properties. Now the conditions that require the circuit protections are, means various types of the faults are going to occur into the circuits. Major the faults we can say there are the short circuits are there, due to which overcurrent problems are there, over voltage problems are there, or overall that are going to generate the more amount or the excessive amount of the heats into the system, into the circuits, into the equipments. Now to remove all these things, or to remove all these parameters which are the excessive one into the system, we want to do the protection, and the protection is going to done with the help of the various protective apparatus equipments. Now that equipments are, we are very familiar with all these things. First one is the fuse, second is the MCB, which is the miniature circuit breaker, the third one is the ELCB, which is the earth leakage circuit breaker, a fourth one is the relay. These all equipments are going to be used for the protection purpose. So mind well, they all are going to connected into the series, because when we go with all these equipments, all the equipments, what happened in series, when that these equipments are going to open the circuit, current is not going to flow, and eventually or overall we are going to achieve the solution of our fault or the problem. Let's go with the first one, and that is the fuses. Now fuse, generally we know everybody, the fuse, that fuse is going to connect in series of the circuit at the starting point. Let's go to the basic of that one. So fuse, in normal working condition of any electrical network, over here the electrical network, by means of the electrical network means we are talking about the any circuit or the equipments, the electrical current or electric current flows through the network within the rated limit. So when the circuit is normal, everything is going to be in normal condition, no fault condition is there at all. What happened? Current is going to flow within the rated limit. Now when it is not going to flow into the rated limit, means excessive parameters are going to increase. What happened? That is going to happen due to the problem which generally or mainly includes the line to line fault, phase to phase short circuit condition, or line to ground fault, that is the phase to ground fault, and the network current crosses the rated limit. Means now limit is going to increase, fault condition is there, abnormal condition is there. One have to protect the circuit as well as the human or live parts which are using that particular equipment or the circuit. Now the high current electric current have the very high thermal effect. Now this thermal effect means the heating effect which can cause the damage to the equipments which are connected into the network. So what we want to do, this high fault current should be interrupted as early as possible, and for making it we have to detect, as we said earlier, we have to detect is as early as possible. But what is the fuse? The fuse of an electrical circuit is a weakest part. Now don't have the confusion over here, because if that is going to be the strongest part of the circuit, what happens? Circuit is never going to be into the break condition, circuit is never going to be into the open condition, and the fault is still is going to exist, and that's why it is going to be the weakest part of the circuit which breaks when more than predetermined current flows through it. It means that if current is going to reach over the limit, then the fuse is going to open that circuit. How it is going to do? We will look at into that one. What is the fuse? Now fuse do that, it is the weakest part, it is going to open the circuit. How it is going to be there into the construction? A fuse is a metal wire which is connected in series with a circuit to protect the circuit in the event of a short circuit or excessive overload condition. Means that metal wire is connected, a thin wire is connected with respect to circuit or the equipment which is going to be in series, and that when the event is there or the condition is there of the short circuit or excessive parameter or overload condition or the fault condition overall, the fuse is going to open that circuit. Now fuse has basic two functions, important one. The first basic function of the fuse is to carry the current during the normal condition without malfunctioning. Malfunctioning means wrong operation. Over here let me highlight this one. Malfunctioning means the wrong operation. It means that it has to carry the intended current, calculate the rated current of the circuitry during the normal operation. If we detect it, or if we say it into the another words, it may not happen that circuit is working properly and now fuse is going to have the operation, it is opening and the circuit is going to stop the working into the actual condition. So that is mean by the malfunctioning. So it has to take that rated current during the OK condition, during the normal condition, that what it means. But at the same time, the second important function is that to interrupt in case of excess current is there. Now we are talking about the abnormal conditions. So when abnormal conditions are going to be there, fuse has to start its work in whatever manner. We will go into that one into the next slide. So it has to open in that case, then and then the actual protection is going to be there. So it has to work properly into the normal condition, but when the abnormal conditions are going to be there, it has to start work for the protection side, it has to start the opening side. For doing the same, the fusing factor is going to be the important one. Now fusing factor means simply the factor which is related with the fuse operation, that is known as the fusing factor. Now fusing factor is defined as the ratio. It is the ratio of the minimum fusing current. Now the minimum fusing current means the smallest current which can cause the melting of the fuse wire to the rated current. Now rated means the healthy current, what we have calculated or what we have intended that our system is going to carry this amount of the current into the healthy condition. So that current is going to known as the rated current or the healthy current. So my fusing factor is equal to what? Minimum current, fusing current with respect to the healthy current. That smallest current has to take by the fuse with respect to the healthy current. Equation for the same, fusing factor is equal to what we have said, minimum fusing current with respect to the rated current. Now that fusing current is actually going to decide or depends on to the fusing factor, the melting of the wire and the opening of the fuse, and actually the protection of the circuit is depends on to that one. So the fusing factor is normally 1.9 for the semi-enclosed rewired fuse, what we have seen generally till date before 15 to 20 years, and which are used for the low voltage domestic use as well as commercial installation. And the higher version of that fuse, which is the rewired fuse, that are the cartridge fuse or the HRC fuse. For the same, the fusing factor is equal to 1.45. We'll go with the diagram of the normal fuse or the rewired fuse and the HRC fuse. Now fusing current is given by, that is equal to K into D raised to 1.5. This equation is very much important, and this will give the actually the technological thing or technical thing with respect to the designing or the connection of the wire of the fuse. Now where my D is equal to the, or D related to the, or stands for the diameter of the fuse wire. Now we cannot take any gauge wire for the fusing purpose. The diameter is very much important. Similarly, K is depends on to the material. Again, we cannot take any kind of the material for the fuse and wiring purpose. We can connect it and it is going to work. Yes, it is going to work, but it may happen that our equipment or circuits are going to be burn out, but our fuse are not going to be, or fuse is not going to be burn out. So that's why melting is very much important into the case of fuse, and diameter and the K both are very precise quantity with respect to fuse at the primary stage, and we have to take very care of the same. Now here are some diagrams related to the fuse. I would like to highlight that this is very common one. If we go with the any stabilizer onto the refrigerator or the television in past few years, you will find out, or some electronic circuitry, you will find out such kind of the fuse. These are the glass fuses are there. In the glass fuse we can able to see there, here some wire is there. Now fuse is going to connect in series. So suppose incoming line, outgoing line, or incoming side, outgoing side is there, and in between fuse is there. So this melting of the wire is very much important as we talk. So K and D, they both are related to this wire. So now if gauge of the wire or the diameter of the wire is not proper, at the same time the material quantity or that is not proper, what happened? This wire is not going to melt at a excess condition or the abnormal condition, and that is going to create the problem, because in that time this circuit is going to still continue, and it may happen due to the excess current, the equipment is going to burn out, not the fuse. Actually that's why the fuse is the weakest part, because fuse is going to break down or that wire is going to melt, and in that way it is going to give the protection to the circuitry. Another types of some fuse are there. A symbol you will find into the some circuitry over there. This is the another symbol of the fuse. Cartridge fuse. The cartridge fuse is the one of the step ahead of the our normal or the rewired fuse. So cartridge fuse has the more capacity ratings to deal with the circuitry, and that's why it is going to use for the higher purpose. Higher purpose means it is going to use from most over the industrial side, and one of the fuse is the HRC fuse, that is the high rupturing capacity fuses are there. Now that fuses are, as its rating is going to more power rating, what happened, they are built with the ability of the quenching of the arc, because when normal or the domestic side condition is there, that wire is going to melt, it may happen that arc is not going to generate, and if it is going to generate, not up to that extent that can damage that particular fuse side. But into the industrial side, what happened? The capacity or the rating of the equipments or the circuits is high, and that's why we have to deal with the higher amount of the power or the energy. So fuse is going to capture that particular energy, so the whatever the arc is going to generate inside the fuse, it has to quench. So that type of the mediums are going to use into this particular fuses, which are the cartridge fuse or the HRC fuse. Now the operation of this particular fuses are more precise compared to the previously what we have discussed. Obviously their operation is better, working is better, but what happened, that initial cost is going to be the higher. At the same time, the replacement cost is also going to be higher, because we cannot rewire it. Once if it is blown down, we have to replace it simply. But the previous discussed normal fuse, we can rewire that fuse for the domestic purpose. And as we said, they are used for the protection of the low voltage feeder and the motor protections. This is the construction of the HRC fuse. This is the fuse element, means whatever the wire we have talked about. The filling powder, which was not present into the previous case. So this filling powder is very much important, and that is going to quench the arc. Otherwise the operating principle is same. Incoming line we can say, outgoing line is same, and they both are, or the fuse is going to connect into the series. But whenever it is melting is there or fault condition is there, this wire or this fuse element is going to have a breakdown, and it may happen due to high capacity. The arc is going to generate, and that filling powder is going to quench the arc. One of the construction of the HRC fuse, as we can say, we cannot rewire the same, and that's why the cost is going to be higher, and we have to replace straight away if it is blown out. And that's why operation or the requirement, as per the requirement, the precision can be achieved, but the cost is going to be the higher. The next one is the MCB, that is the miniature circuit breaker. So what right now in today's scenario, at so many institute at the domestic side, we are able to see now fuses are mostly replaced at the incoming side, means when the major line is coming at the domestic side or the industrial side, with the help of the miniature circuits breaker. Now in modern practice, more commonly MCB is used for the low voltage electrical network instead of fuse, because MCB has the advantages. Now whatever the advantages